Welcome back again to Advanced Functions, MHF4U 1. This is Combinations of Functions chapter. In this lesson number 2, we're going to understand how we can combine two functions by looking at the sum and the differences, both graphically and algebraically. Let's go over the definitions that we learned from the first lesson. The sum and the differences of two functions are defined by this. So this is the sum. So when you're adding two functions, you can separate it into the same input of x. And this is a difference. The input is same, so you can separate it as f at x minus g of x. The domain for the sum or difference of the two functions is their intersections of their domains. So whether it be plus or minus, this represents that two functions, when they intersect, that will be their arithmetic domain. Okay, so we're given function f and function g of x, and we're actually given a list of points. The question is, find the domain of f plus g of x. So that means when they're adding, we have to figure out where they intersect. So domain for function f is 1, 2, and 3. Domain for function g is 2, 3, and 4. So this is my x value. But if we're adding it, then it will be domain for f plus g. It will be where they intersect. So it looks like 2, they overlap, and 3 as well. So 2 and 3. So that will be the domain for f plus g. Okay, now what about we are looking for this expression? We're adding the two functions. That means you have to first figure out the x value where they overlap. So it would be 2 and 3 only. And so you're going to keep the x value the same. And for y value, you're actually going to do the addition. So therefore, let's see. So 2 stays the same. So 2, it will be -5 and -2. And we're going to add that. So -5 plus -2. That's my first domain. And then first point. And then at 3, my range is 7 and 3. So we're going to do 7 plus 3. And that's my list of points. Therefore, if I have to simplify, it's going to be 2, -7, and 3, 10. So as you can see, if we're combining functions, whether addition or subtraction, your goal is to keep x value the same. And same, what I mean is they stay as it is, but before you do that, make sure you have to figure out where the domain of function f intersects with domain of function g. Okay, and then you're going to do the operations for y values only. Okay, and then you will get a new function. So this will be my final answer. So we're given f of x and g of x. So we have a parabola and linear. And determine f plus gx. Okay, so we're sharing the same input of x. So I'm going to separate it. F of x plus g of x. So that means f of x is -x squared plus 3. G of x is plus -2x. Then we're going to collect like terms, but it looks like there are no like terms, so I'm going to put it in an order of degree, -2, x, and +3. And that will be my new combined functions. Okay, so this time it's subtraction with the same input of x. So I'm going to separate f of x minus g of x. So f of x again is -x² +3 minus -2x. So again, there are no like terms, but let's put it in order, +2x and +3. And that will be my function. Now, what about, as an extra question, what about the domain of f plus g? Okay, for the first one. Then, where do they overlap? Well, just by looking at the finished function, you will notice that it's a parabola. If it's a parabola, then x can be any real number. Same thing for subtraction. It's a parabola, so plus or minus will, x can be any real number. Now the functions f and g are given by their graphs, and graph the function f minus g. Okay, so when you're given a list of graphs, first thing is you're going to choose the x value where domain of f intersects with domain of g, okay? And then you're going to subtract, because it's a subtraction, subtract the y values. Okay? So the best thing is, where do they intersect? So for example, I can choose at, okay, but I want to choose something that's clear. So let's say they intersect at -1. So I'm going to choose points at -1 here. And I'm going to choose a point that's pretty clear at 1 here. And let's choose a point that is pretty clear at 3. So after I figure out where the graphs two intersect, okay, and what I can do is I'm going to subtract the y values. But be careful, we're subtracting f minus g. So at -1, I'm doing the blue graph minus the red graph. So blue graph, the y value is 0. And for g, it's -0.5. So it's going to be 0 minus -0.5, which is going to give me 0.5. So at -1, my new point is going to be at 0.5. Next, I'm going to do 2 minus -0.5. So it's going to give me 2.5. And then at 3, I'm going to do 4 minus 3.5. And that will give me 0.5. Okay, let's do one more. Let's do at -3. So at -3, my y value for the red graph, it's going to be 3.5 minus -2. And that will give me 5.5 because we're adding it. So at -3, my graph is going to be somewhere here. Okay, so therefore, this is my graph. So I could connect the points. Okay, and let's just double check. At 1, so it's going to be 2. So it's going to be somewhere that looks like that. And here. Okay. And I'm just going to erase this. Yes. Now, when you're getting a new graph, keep in mind that when two functions are the same family, then you're going to get exactly the same family when you're adding or subtracting. So for example, if I'm adding two linear functions, you're going to get a linear. if I'm adding two quadratic functions, then you're going to get two quadratic functions. But if you were to add or subtract two different functions, then you may not necessarily get a linear or a quadratic. Okay, so same thing applies for subtraction as well. Question 4. Find the domain of the sum of the given function. Okay, so first function, where it's a linear function, and this is 1 over x squared. So if you are given a functions that are not like out of the norm, so for example, it's 1 over x squared, so this is a special type of function. So you will use a Desmos to figure out how it looks like. If not, you could use a table of values. So domain for this one, for the first function, is x can be any real number. For the second function, you will notice that it will be domain is x can be any real number, but it cannot equal to 0. So if you were to use a Desmos, it will look something like this. Okay. So if I were to combine them, so domain for f plus g, then it's going to be any real number except 0. So you could say x can be any real number such that x cannot be 0, and that's it. That's where the two graphs will overlap. Letter B, so we're given a square root function and the logarithmic function. So domain for f, for this one, it's going to be, we want to make sure that 2 minus 1, x is greater than or equal to 0. So that means x is less than or equal to 2. So x has to be less than or equal to 2. Keep in mind, x can be any real number. For logarithm, we want x plus 1 to be greater than 0, right? So x is greater than negative 1. So domain for function g, the restriction is x is greater than negative 1. So therefore, if we were to combine the two, where they overlap, it's going to be, so if I were to rewrite this, I can rewrite it as x is negative infinity, 2, and this is negative 1 infinity. Therefore, it's going to be negative 1, where they overlap, in 2, and close the bracket. And that will be my final answer in a set notation.